Okay, so let's start, and we first import the necessary libraries to this um, to this notebook, and we create this list, and then we run a sanity check to make sure everything is fine. So you can see here that we're just checking if the shape of the trained images and the test images are really 6,000, 60,000 by 28 by 28. So this is basically question one. Now, question two, we check the length of the labels, and then we use the method len, and we make sure that the len of the trained labels is really 60,000 and the test labels is 10,000. So question three, we print 10 values representing the categories of the clothing up there from train and test. And yeah, I guess that is it. Okay, so question four. Here we're just printing raw pixels from from trained images on index 5 from 0 to 25. Okay, now question 5. Here we're plotting using matplotlib. We're plotting the image on index 5 so it can be visually represented. And yeah. So question 6, we check if the label matches the class name, and well, it does. Index 5 actually, which is the same image here, and it's a pullover. Okay, now question 7, it's almost the same as question 4, but we're just checking, we're doing the same, but on index 500 from test images. Now let's go to question 8, and we're doing basically the same thing as question 5, but here we're doing for test images on index 500. And again, question 9, just like question 5, but same thing we did before, test labels on index 500. Okay, question 10, we're going to import models and layers from TensorFlow Keras by Google. And question 11, we're going to add some sequential models. And question 12, we're going to flatten these layers. And question 13, we're going to convert we're going to convert the images to float numbers because, if I'm not mistaken, according to one of the labs we had with Professor Mark, the closest these numbers, because they're going to be float numbers, so they're going to be like between 0 and 1, and the closest they are to 1, this means that there is a strong pattern there, so there is some sort of behavior pattern which the model can identify, like check if there is a real pattern. If there isn't any, if they're close to 0, this means that this pattern is not really strong. And then we add 512 neurons with ReLU activation, and right after that we're going to add 128 neurons also with ReLU activation. Okay, so let's go to question 16. And question 16, we do 10 neurons here because there's 10 clothing categories, and then Y softmax because it kind of converts the outputs into probabilities that sum into 1. So that's question 16. Okay, so now we're going to talk about question 17, and here in question 17 we used Atom and RMS prop. Atom is usually faster and more stable, and so sparse cross entropy takes labels as integers. Regular cross entropy needs one hot encoded labels. Same calculation, but different input format. Okay, so question 18. Let's go to question 18. Here we ran 10 epochs, and with validation split to check if it's memorizing or indeed learning. We can check here the loss, and if the loss is down and accuracy up, this means that the model is indeed being trained. If not, then it means that the model is memorizing, which is overfitting. Overfitting is when the model stops learning and starts memorizing because of the patterns. So if a model has to run 10 epochs, or let's say 100 epochs for a very small data set, it's going to start memorizing instead of learning, and this is overfitting. So let's go to question 19. So yeah, here at question 19, I just wrote this answer to be brief, but my explanation is that MNIST is actually a data set of it's a data set usually used as it's like the hello world of the machine learning field, and but it's a number, it's digit data set. Now FashionNIST is an image data set, so it makes it harder. So that's the difference between FashionNIST and MNIST. Question 20. So just like the answer there, when it comes to FashionNIST, it's an image data set, so it's a bit harder for the model to kind of differentiate between them. So like shirt, t-shirt, like there, and any other images, it becomes harder for the model to see the differences between them. Now, digits are a lot easier for the model to see. So that means that the accuracy is a lot higher when it comes to digits, and for images, it's the accuracy is slow. Okay, question 21, just like we said on question 18, there is overfitting because although this is fashionist is an image data set, even though it's hard for the model to train, it's still tiny blocks is still too much for this data set. So it starts memorizing instead of being trained. And yeah, that's it. That's the so we do have overfitting. And now, in order to avoid overfitting, we could have a larger data set or ran fewer epochs. That's when the model starts training much better. So that was machine learning assignment 1. Thank you.